Hello everyone, my name is Chiranjeev Mohanty and this video is all about the data science project named Diabetes Prediction. I have made this project using Python and machine learning. For this project, we will need certain things, that is, one is dataset and second is a coding environment where we can write code and execute, that is Jupyter Notebook. First of all, for dataset, we have to go to Google and type Kaggle. I have taken the dataset from Kaggle, that is a website provided by Google. Basically, you can go to the Kaggle site by just typing Kaggle in search bar, like you can see. Now click on kaggle.com. Here is a dataset. You can click here and just write diabetes prediction, and we will find the number of datasets are being provided here. And I have chosen this dataset for diabetes prediction. Now let's go to our coding part. This is the Jupyter Notebook where I have written my code and had executed it successfully. For that, for diabetes prediction, I have used certain libraries like numpy, pandas, matplotlib, synbon, sklearn. Also, let me explain you what is numpy, pandas, matplotlib, synbon and sklearn. Numpy is basically provides me why I use this numpy and these libraries. Numpy provides me multi-dimensional arrays, so that I can put any array or something multi-dimensionally. Pandas provides me high performance, easy to use structures and data analysis. For data analyzing and for data reading, I have taken pandas. And for sklearn, why I choose sklearn, because it provides a lot of efficient tools for machine learning and statistical modeling, which includes classification, regression and etc. And I have also imported certain packages from sklearn, that is standard scalar, for train split and accuracy and classifier also, and cross-val, logistic regression, and confusion matrix, plot confusion, and all of this. Basically, synbon and matplotlib both are similar. This is basically used for data visualization library. This has gone. This all data libraries I have taken for now. Next, after I will run this, it is showing no result. That means the code that has been written and the import project, the library and packages that is imported are fine. This from the dataset. This code is for dataset loading. Column names. These are the columns that are when provided inside the dataset, and this is the dataset.csv. .head file. This .head function basically visualize few rows of dataset. I have taken 10 of them. The shape of ds.shape. This code provides or gives the output for how many number of rows and columns present in the data set. .info. This info function shows the whole entire function of the data set, that is number of rows, number of columns, name of each columns, and these are null, non-null, the data types and all of this. The memory uses, how much memory it has consumed, the types, data types, and all of this. Mm, the dataset has certain categories among which we will take the input and proceed for prediction of data for diabetes. There is number of times of pregnant, plasma glucose concentration tolerance test, and diastolic blood pressure, triceps skin fold thickness, 2-hour serum, insulin, BMI, that is body mass index, diabetes pedigree, function, age, and the class variable. The class variable is basically a outcome. This machine will take the all of these as an input and will predict whether the value is 0 or 1. 0 is for non-diabetes and 1 is for diabetes. And this code will set all of this to 0. ds.isNull method.sum. These are the array that it shows ds.unique, that are unique variables, number of count, number of zeros, and non-diabetic in the data set. Non-diabetic patients are 1316 and number of diabetes are 684. This provides the length of this particular sets. Plasma glucose concentration tolerance test, body mass index, and diastolic blood pressure. This length function defines the length of these sets. Now I have taken the x variable because it's time for us to train our model. To train our model, we have to find number of the length and the x-axis and the y-axis. Y-axis is basically for the output, and x-axis it provides the data or data that is going to be provided to the machine. X train comma x test, x y train y test equals to a train test split. I have here called the train test split function, so that I have also taken the random. For training purposes, and if I run this, then it will come to here, and this is the result. The length of each test y and x is 172, and this is the matplot here. I have considered decision tree classifier. There are lots of classifier available inside sklearn. You can choose any of one, but I have taken decision tree classifier, and this is the plot. This code shows this, and for the next plotting or subplot, these are the non-diabetes labels that is doing. Tree path functions. After this, all of this, now it's time for us to show whether the model that is being I have prepared or made, what is the accuracy of the model. This is the accuracy graph. Training test is set to 1, but my training test for the model is 0.95. The accuracy is 0.95, and this is the code print max training test scores, and this code shows what is the accuracy, and I have got 0.96. and the mean score for the test is 0.95. This is the diabetes prediction I have made. Thank you.